In this chapter, we are looking at inequalities, and in this particular lesson, we're going to be looking more at just some terminology and some different ways of representing our answers or solutions, because when you're dealing with inequalities, you have more than one solution. So how do we write that? To get us started, let's look at our key terms. An inequality is a number sentence with less than, greater than, less than or equal to, or greater than or equal to as its verb. A graph of an inequality is a drawing that represents its solutions. The sentences x plus 4 less than 10 and x less than 6 are equivalent since they have the same solution set. And the solution set x such that x is greater than 2 is written using what we call set builder notation. We also have something called interval notation that we will be looking at. Before we look at the different notation and different ways to represent answers and solutions, let's just practice working with our inequality symbols. So here we have x is less than or equal to 6. So we need to determine, is 0 less than or equal to negative 6? The answer to that is no, because if you think of a number line, the number on the left is always the smaller number. Negative 6 is definitely less than 0. 0 is definitely greater than or equal to negative 6. Is negative 3 less than or equal to negative 6? And the answer to that is also no. Is negative 6 less than or equal to negative 6? Yes, because of the equal to part. Is negative 9 less than or equal to negative 6? And the answer to that is yes. Negative 9 is definitely on the left on a number line compared to negative 6. And is negative 5.4 less than or equal to negative 6? And the answer to that is no. So now let's look at something called interval notation. Number 7 is written in what we call set builder notation, and if we just visualize this on a graph, what this means is if we read it from the variable, which is in the middle, we can say x is greater than negative 3, so we would shade to the right, but less than 6, so we would have a parenthesis at negative 3 and another one at 6 and shaded in between. This means all the numbers between negative 3 and 6 fit the criteria. When we go to write this in interval notation, our interval notation looks a lot like our graph. We use parentheses, we have a comma, and the lowest it can be is negative 3 and the highest it can be is 6. And so that would be our interval notation for number 7. Now let's look at number 8. If I was to graph this one on a number line, I would have the number 3. I went greater than or equal to, so I would have a bracket, and I would shade everything to the right. So what would this look like in interval notation? Well, I'd have my bracket. The lowest it can be is 3, comma, what's the highest it can be? Well, positive infinity. So that's my interval notation for number 8. Number 9, again, I like to graph it. It gives me a really good visual. I have less than negative 4, so less than would be a parenthesis. If it was equal to, it would have been a bracket, but it doesn't have that, so it's just a parenthesis, and we are going to the left because of less than. So we would have a parenthesis, and negative 4 is the highest number. This time I don't know the lowest number, so it would be negative infinity. And there's my interval notation for that one. Now let's actually solve an inequality, and we will write our answer in interval notation. We solve inequalities the same way we solve equations. So in 21, I definitely have some like terms that I can combine. 5x negative 4x is simply 1x. I still have plus 2. And then I would have to subtract 2. And that's going to give me x is less than or equal to 11. Depending on the directions, if we were to write this in set builder notation, we would just throw in our symbols, and the squiggly brackets means a set of numbers or a collection of numbers, x such that x has to be less than or equal to 11. So that's set builder notation. If we were to write it in interval notation, then I like to graph it, and graphing is another way to represent our answer. But it would be a bracket, and I would shade to the left. That's what the graph would look like, which means my interval notation, my highest number it could be would be 11, and it's going to negative infinity. So depending on how the problem wants you to write the answer, we have interval notation, set builder notation, and a graph. Okay, let's solve number 22. On the right, I can combine some like terms. I have negative 11x and negative 8, so it's a negative 19x. Then I would need to collect all of my variables on one side. So I like my variables to be on the left, especially with inequalities. It makes it so much easier to graph and write it in the proper form. That's going to leave me 6 minus 1x is less than or equal to 5. Now I need to subtract 6 from both sides. And that's going to leave me with negative x less than or equal to negative 1. And then to get x by itself, I have to divide by negative 1, which is going to leave me x greater than or equal to positive 1. Remember that when you solve inequalities and you have to multiply or divide by negative, then you have to reverse your symbol. So I have x greater than or equal to 1. Now, that's not in set builder or interval notation. So in order to be in set builder, we would throw in some of our symbols. And if I wanted interval notation, we need everything greater than or equal to 1. So 1 would be the lowest number. It would be a bracket because it's equal to, and it would go to positive infinity. So just depending on how you need to write your answer, just make sure you read the directions in my math lab, and it'll tell you if it wants set builder or if it wants interval notation.